Okay, welcome back. Now we're going to deal with radicals. Now, the way you deal with radicals, and again, you might have forgotten about this from algebra, but again, I'm going to think of it from an algebra point of view, from college algebra or pre-calculus, and then we'll use limits. So what they want us to do here is they want us to find the limit as x goes to positive infinity for this, and as x goes to negative infinity. So we'll handle both of them separately, see what happens. But let's just think about this. So we've got a rational expression that involves a radical. Now, what's the technique that we learned before? We want to divide the top and the bottom by the largest power of the denominator. Well, we've got this radical, so let's think about this. So what happens to the square root of 4x squared plus 5 as x gets really, really big, negative or positive? How does this change, well not change, how would we look at the end behavior? Well, as x is getting really big, positive or negative, this thing is growing really, really fast. This is staying the same. So we could say for really large values of x, either positive or negative, this can be approximated by the square root of 4x squared, which then is equal to what? It's equal to 2 times the absolute value of x. Why do I put the absolute value of x? Because we're dealing with x squared, the square root of x squared. Okay? So, how does that help me? Well, remember, if I'm going to divide by the largest power of x in the denominator, I have to take into consideration the square root. So the largest power of x in the denominator is not x squared. It's the square root of x squared. So what I would do is I would divide the top and the bottom by the absolute value of x. Okay? Or just 1 over, or divide by x. Okay? And then realize that we're going to take the negative and positive values of it. Okay, so now here's the thing. If I do that, what happens to this? Well, let's just do that. So if I divide the top and the bottom by 1 over x, or divide by x, okay? So I get 3x minus 2 divided by x, and then I get 4x squared plus 5 divided by x. Okay? Now, if you wanted to put the absolute value of x here, that's fine. Okay? So now what happens? Well, this is going to become what? This is going to become how do I want to do this? Well, actually, it doesn't matter. So this is going to become 3 minus 2 divided by the absolute value of x. So that'll be what the numerator turns into. The denominator, now what I'm going to do is, you can pull this out and write this as multiplying by 1 over the absolute value of x. Now, in order to simplify this, I have to bring this inside the radical. Well, when I do that, it basically, I'm going to change this. So here, let me write it out here. So 1 over the absolute value of x is the same as 1 over the square root of x squared. So if I bring it in, I just have to use this, and then I can bring it inside, and then what happens? I get the square root of 4 x squared divided by x squared plus 5 divided by x squared. So I have to bring it inside the radical, okay, as a square root. So, and this is what does it for me. Okay? And so now I can simplify the denominator and I get this. 3 minus 2 over the absolute value of x in the numerator, and the denominator becomes what? The square root of 4 plus 5 over x squared. Okay, so now this is what I can take the limit of. Okay, so now let's take the limit as x approaches positive infinity of this. So this will be 3 minus 2 over the absolute value of x divided by the quantity square root 4 plus 5 divided by x squared. Now, okay, so now here's the thing. What happens to this as this goes to positive infinity? Well, before I go on, let me see here. This I'm going to drop the absolute value signs because it matters, right? Okay. Depending on what x is. Okay. So that's going to be important. Because eventually we're going to have to drop the absolute value signs in the numerator. Okay, so now, as x goes to positive infinity, this is going to 0, right? So this is going to equal 3 minus 0 divided by the square root of 4 plus 0, right? So all I'm using is the limits. Okay, and the reason why I'm dropping the absolute value signs is because once I bring it inside, then I can drop the absolute value signs, because once it's outside I had to have the absolute value signs to cancel with the numerator. But once I bring it inside the square root, once I bring it into the square root, I can drop the absolute value signs, and then I drop the absolute value sign here as well. Now, The question then becomes, is here, so I distributed too soon. Because again, I missed something when I divide this out. So let's write this as 1 over x times 3x minus 2. Okay, so let's not distribute. I got ahead of myself because that I'm going to lose information. You'll see why. Because if I stuck with this, I'm going to get the same answer whether I go to positive or negative infinity. So that would be a mistake because I lost information when I distributed. So let's write this as 1 over x times 3x minus 2. Okay, so now as x goes to positive infinity, this is going to what? This is positive, right? And so if this is positive, then when I distribute, then you'll see what happens when well, you'll see in a moment. So now if I distribute, now it becomes the limit as x approaches infinity of 3 minus 2 over x over the square root of 4 plus 5 divided by x squared. Okay? And now this, as you saw earlier, goes to 3 minus 0 over the square root of 4 plus 0, which equals 3 over the square root of 4, which is 2. Okay, now, so far so good. But now let's go to negative infinity. So the limit as x approaches negative infinity of the same thing. So I'm going to go to now. Since I'm dropping the absolute value sign, then I have to, as x goes to negative infinity, I'm going to put a negative sign out here. Okay? Because remember, if I drop the absolute value sign, right? If I drop the absolute value sign and it's negative, I'm doing the opposite of whatever x is. Okay? So now this is going to be 3x minus 2 over the square root of 4 plus 5 divided by x squared. Okay, now if I distribute the negative 1 over x, now it becomes what? Negative 3 plus 2 over x over 4 plus 5 divided by x squared. And now you see what's going on. Now as, oh, there should be a limit here. This should be a limit. I forgot my limit. And so it's the limit as x approaches negative infinity of this thing, and then what happens? Well, I'm going to get negative 3 on the top, and I'm going to get 2 on the bottom, so I get negative 3 halves. Okay? So notice that the limit as x goes to positive infinity is positive 3 halves, and the limit as x goes to negative infinity is negative 3 halves. Okay? And we've seen this type of graph before, right? All right. That's it. Have a great day.